SSH or Secure Shell is a protocol for securely connecting to and interacting with a remote computer. It uses encryption to secure the connection and provide a secure way to log in, execute commands, and transfer data. SSH is commonly used to log into servers and workstations remotely and is a common way of managing and configuring network devices such as routers and switches. SSH supersedes several older, less secure protocols for remote access and management, such as telnet and rlogin. Telnet is an older protocol that allows remote login to a server using a clear text username and password, making it vulnerable to eavesdropping and interception. Rlogin, also known as remote login, allows a user to log into a remote system and run commands, but also in clear text. Both telnet and rlogin do not encrypt the traffic between the client and the server, which can be intercepted by attackers. SSH allows users to authenticate themselves using public key cryptography, which is more secure than simple password-based authentication. Public key cryptography, also known as asymmetric cryptography, is a method of encrypting and signing data that uses a pair of keys, a public key and a private key. The public key is used to encrypt data, and the private key is used to decrypt it. Conversely, the private key is used to sign data, and the public key is used to verify the signature. A user can share their public key with anyone, allowing others to encrypt messages and verify signatures. However, the private key must be kept secret and should only be accessible to the owner. One of the main advantages of public key cryptography is that it allows for secure communication without the need to securely share a secret key beforehand. For example, in SSH, the client uses the server's public key to encrypt a session key, which is then decrypted on the server using its private key. This allows the client and server to securely exchange data without ever having to share a secret key. Here's an example of how public key cryptography works in practice using the example of SSH. Alice wants to connect to Bob's server using SSH. Bob generates a public-private key pair using the SSH keygen command on his server. He keeps the private key on his server and shares the public key with Alice. Alice adds Bob's public key to her /.ssh/authorized_keys file on her local machine. Alice initiates an SSH connection to Bob's server. Bob's server responds with its public key, which is then stored in Alice's /.ssh/known_hosts file. Alice encrypts a session key, using Bob's public key. She sends the encrypted session key to the server. Bob's server receives the encrypted session key and uses its private key to decrypt it. Now that Bob's server and Alice have the same session key, they can use it to encrypt all further communication using a symmetric key algorithm like ICE. Bob's server authenticates Alice by comparing the identity of the client, who has to prove it has the private key corresponding to the public key Alice previously added to her authorized_keys file. If the authentication is successful, Alice is granted access to the server and can now run commands and transfer files securely. SSH is also used on many other applications and protocols such as SSL/TLS, PGP, and Bitcoin among others. Public key cryptography is generally considered to be very secure, as long as it is implemented correctly and the keys are properly managed. The security of public key cryptography is based on the assumption that certain mathematical problems, such as factoring large integers or computing discrete logarithms, are hard to solve. For example, in the case of RSA, a commonly used public key algorithm, the security is based on the difficulty of factoring large composite numbers. However, there are some potential weaknesses in public key cryptography. For example, a sufficiently powerful quantum computer may be able to solve the mathematical problems that public key cryptography is based on, potentially breaking the encryption. Additionally, if the private key is lost or stolen or the algorithm is broken, the encryption becomes compromised. Therefore, it's important that the key is generated and stored securely, for example, by keeping it in a hardware security module, HSM, and using a safe communication channel. It's also important to note that public key cryptography only encrypts the data transfer, the authenticity of the sender, and the confidentiality of the data. But it doesn't provide integrity of the data. For that, other mechanisms such as message authentication codes, MAC, or a digital signature algorithm is usually used. In Linux and Mac, you can generate a public-private key pair using the SSH keygen command. The SSH keygen command is included with the Open SSH package, which is typically installed by default on most Linux distributions. Here is an example of how to use the SSH keygen command to generate a new RSA key pair. When you run this command, you will be prompted to enter a file in which to save the key and a passphrase. By default, the keys will be saved in the /.ssh directory, and the file names will be i.d._rsa for the private key and i.d._rsa.pub for the public key. You can also use the F option to specify a different file name. This will generate the key pair with the name mykey and mykey.pub in the current directory. The passphrase is used to protect your private key. You can leave the passphrase blank if you don't want to use one. For other algorithms, you can use the T option, for example for DSA. It's important to use a strong passphrase and to keep your private key secure, as anyone with access to your private key will be able to access any servers or services that use it for authentication. API tokens and SSH are both methods of authentication that are used to secure access to servers and services. However, they are used in different contexts and serve different purposes. An API token is a string of characters that is generated by an application and is used to authenticate requests to an API. API tokens are commonly used in web services and microservices to authenticate and authorize requests. Other secure authentication methods include OAuth/OpenID is an open standard for authorization and can be used as an authentication method for users. OAuth, Open Authorization, is an open standard for authorization that is used to grant access to protected resources, such as an API. It is a mechanism for allowing third-party applications to access resources on behalf of a user, without requiring the user to provide their credentials to the third-party application. OAuth is mainly a way to delegate access. SSH instead is a way to access a system remotely. Two-factor authentication requires two forms of authentication, such as a password and a one-time token generated by an app or received via SMS. Single sign-on, SSO, allows users to log in once and access multiple applications with a single set of credentials. It's worth noting that none of the methods are mutually exclusive. You can use multiple methods together to improve security. For example, you can use an API token to authenticate an application, and then use SSH to securely connect to the remote server.